Good evening, everybody. We are now on night 7 of our Lambda School mini bootcamp. So we are heading to the home stretch here, just tonight and tomorrow left. So thanks for sticking with me and learning all about JavaScript. My name is Deandra Ryan Moss. I'm an instructor at Lambda School, and I will be teaching you live from Bisbee, Arizona tonight. So if you want to be interactive, make comments or questions during the lecture, and ask questions at the end, please join the Slack channel. It's the NBC May 7th Slack channel, and that is the best way to, and really the only way to communicate with me during the lecture. So to all you guys on the YouTube chat, sorry, I don't monitor it, so make sure you're on Slack. Anyways, let's go ahead and talk a little bit about Lambda School and this mini bootcamp. For anyone who's joining us or anyone who has amnesia from the last few nights, you can learn all about what Lambda School is and what this mini bootcamp is as well. So Lambda School is awesome. It is a 6-month computer science and web development immersive that is entirely online. So it is a 6-month program. It's a full-time school. That means Monday through Friday during your regular work hours. And when you attend Lambda School, though it's remote, it's a blend of a lot of different learning styles. So there will be live lectures, there will be group work, there will be homework time, Q&As, pretty much everything you need to learn a bit about programming. And throughout that course, we cover all of the important web development topics. So front-end web development, back-end web development, frameworks, as well as diving into some CS topics. So everything you've seen in this mini bootcamp will be fleshed out in great detail, as well as diving into other topics. So it's really everything you need to know to be a web developer, to learn how to make web apps, and especially it gets you all the skills you need to get hired. So another thing that is awesome about Lambda School is that our tuition model is deferred. So you can pay tuition up front if you want, but if you don't want to, you're welcome to pay 0 up front. And the reason that you are welcome to pay 0 up front is, 1, we want to make sure that Lambda School is available to everyone who's ready to learn. And 2, because we are confident that you will get that job that you're coming through Lambda School to get. So once you have a web development job making over $50K, you'll pay back your tuition over the first year or the first 2 years. So that tuition model is really great because it allows us to bring in everybody into Lambda School who's willing and able and ready to learn, and there's not so much of a money barrier to start here. So that's Lambda School for you. I hope that you guys are all getting really excited for the main curriculum. If you're not already enrolled, please reach out to Karen Zachary to apply. Even if you're kind of on the fence and just curious, reach out to her. She can answer any questions that you have. On the topic of this mini bootcamp, if you've been here this long, hopefully you know what we're doing here. If you're new tonight, you might want to check out the new one that starts next Monday, or you can go and see all the videos that are on YouTube because we're pretty deep in the thick of it. Last week, we learned all about HTML, CSS, and some JavaScript fundamentals. And this week, we've been diving a little deeper into JavaScript. So tonight will be more of that. Tonight, we are learning all about classes. So last night, we were introduced to 2 data structures in JavaScript, arrays and objects, both extremely useful for grouping like data. As it were, though, objects are a little more complex than presented at first glance last night. So before we jump into any coding, I want to talk to you a little bit about JavaScript objects. And then tonight with classes, we'll see a really great example of how something really advanced that we can do in JavaScript, which is essentially creating our own new type of data. So let me talk a little bit more about JavaScript objects. So as presented last night, objects are a data structure. They're just like arrays, but slightly different. They're a way of grouping like data together. And that is certainly one use of objects, and that is certainly the most basic use of objects. But objects run much deeper than that. So I am about to drop a pretty awesome truth bomb on you, which is that it turns out that every single thing in JavaScript is actually secretly an object. So of course, objects, when you declare an object with the little curly brackets, those are objects. But it turns out that numbers are also objects. Strings, also objects. Booleans, objects. Arrays, also objects. So that at first glance might seem like, wait, what did she just say? But let me explain it a little more. So behind the scenes, everything is secretly an object. So you can think about it, if you think about JavaScript as being a play, for example, a string would be a variable type it's an object, but it's wearing a string costume. And that means it has all these extra frills. You know, it has the length property. It has all those methods. We've seen a few of those. And so those properties and methods are specific to strings. But underneath that string costume, underneath that extra string functionality, at the base core, strings are just objects. Same thing is true of arrays. Arrays have a length property as well. They also have a bunch of built-in methods. We saw a couple of those last night, like push and pop. So those things are all array specific. Those are part of the array costume. But underneath the costume, arrays are also just objects. Now, objects themselves don't really have a costume on. They would be like the narrator. They're not really trying to pretend to be anything else. They're the most basic thing. There's no extra frills. They're just objects. And one way that we can realize that is that whereas with things like strings or arrays, the methods were already built in or the properties were already built in. But when we declare an object, it's our job to write those ourselves. So that's this kind of crazy idea about everything being an object. I will say that when someone says a JavaScript object, usually they're referring to what we saw last night, which is when you declare something with the curly brackets and you explicitly write out the key value pairs. But sometimes you'll see, you'll hear the word object used differently. You might say, you might refer to anything as being a JavaScript object. So you might hear an array as a type of JavaScript object. In that case, we're using the word object in kind of its true sense, which is that everything is an object. So this idea is a little hard to swallow, especially at the beginning. But as we go through the lecture tonight, I'll keep coming back to this idea, and hopefully it'll start to make a little more sense. But I wanted to mention it from the get-go because I think it's this really important idea to start to really understand what is actually going on behind the scenes in JavaScript. And speaking of behind the scenes, we're going to get a little look into what's really going on tonight because we are going to learn about classes, which, as mentioned, is essentially our way as a JavaScript user to create a new customized JavaScript type. So let me share my screen and we'll do a brief little review of objects and then we will start to talk about classes. So, all right, let's get to it. Okay, up here on the screen, I have declared a JavaScript object. And I'm using the JavaScript object, that word object, in the same way I used it last night, right? It's a variable that I've declared set equal to this object using the curly brackets and these key value pairs. So let's take a look at this thing. I've called it Ninja Assassin, and the contents inside it refer to all the properties of a Ninja Assassin. We have a key called Codename, which is set equal to the string containing the value of Codename, which is the actual name, Hollow Eyes. I have a key or property called Weapon, a key called Stealthy, which notice that this is set equal to a Boolean. We have our head count, which I've started at 0. So this one is a number. And then finally, I have a method called kill. So this kill method is, of course, a function because all methods are functions. And within it, every time you run this function, we increment the head count. So if we want to get some kills under our belt, we use the kill function. As a little terminology reminder, you would refer to all of these as properties on the Ninja Assassin, whereas kill you would call a method because it's a function. So let's check it out. If we want to see one of the properties, we can use dot notation, which we learned last night. If we want to run that kill method, we have to actually use the parentheses to execute it. And then afterwards, we can look inside of our object and see that the head count has incremented. Of course, if we wanted to manually increment the head count, we could always just set it equal to a different number. And then if we look inside of our assassin object, we see that it's been overwritten. So I've just used dot notation to access a value, to execute a method, and to overwrite a property. So all things we saw last night. So there's a little bit of a review of objects. And as a reminder, to tie things back to what I just mentioned about all JavaScript data types being objects, whereas with our strings, like for example, Ninja Assassin .codename is a string, so we can actually add an extra dot on there and look at the length property. So we can see the length of the codename, which is a string. So strings have built-in properties on them, like .length, or I could do to uppercase, which is a built-in method. But with our Ninja Assassin, because it's an object, all these properties and functions, or all these properties and methods are things that we actually wrote ourselves, as you can see here. So there you have it, the Ninja Assassin object. So let's say that I wanted to create a new assassin. So I'm going to call this one Character Assassin. And it's going to have the same kind of properties and methods as this Ninja Assassin, but with different values. So our Character Assassin has a code name. Our Character Assassin also has a weapon. It has a stealthy value, a head count, which I will also start at 0, and then a kill function, which the kill function is going to work exactly the same, so I'll just copy and paste it over. So now we have two different assassins, a Ninja Assassin and a Character Assassin. Let's say we wanted a third one. Well, I just did a lot of typing there, so I'm going to actually copy and paste this over and change this to Ghost Assassin. I'll change the values over here. Ghost Assassin is definitely stealthy. And there we have it. I've just created 3 different assassin objects. So hopefully some alarm bells are going off because we've just violated one of my #1 principles of coding. Don't repeat yourself. So as I've mentioned in a few different lectures, we always want to create dry code, which means code where we do not repeat ourselves. So there's definitely been some repeating here. I mean, to create the Ghost Assassin, I just totally copied and pasted the Character Assassin over and started editing things. If you find yourself copying and pasting code and changing a few values, that's a very good time to stop and think, uh-oh, am I repeating myself? Is there a better way to do this? So as it turns out, yes. So we're creating all these different types of assassins. And there's lots of similarities between them. For example, they all have the same properties and the same method. And the properties do have different values, but there's still a lot of similarities. So in this case, we might say to ourselves, well, if I have to create a bunch of different assassin objects, what if I had an assassin type? What if there were actually a JavaScript type called assassin that had some of these built in already? With strings, it would suck if we had to add in the length property or add in every string method ourselves every time we created a string. That's just built into us so that we can create new strings and not have to repeat some of the logic. Well, we can't truly create a new JavaScript type because those are built in, but we can create something called a class. And a class is essentially our way of creating our own customized JavaScript types. So I'm going to keep these guys up on screen for just a second, but then I'm going to, actually I'll leave them at the top and go ahead down here and start to create a class. So we want our class to be called Assassin because it's not any one particular type of assassin, it's just the general idea of an assassin. So when we're creating a class, this is our starting point. We declare a variable as usual. One thing I want to note is that I've capitalized my variable name. This is something that it's not syntactically required. So if I left it lowercase, I wouldn't get an error. but by convention, we always capitalize when we're creating a class. And that's a good way to indicate to our fellow programmers that this thing is a class. It's important to do that because notice that the syntax for creating a class looks just like a function. So it's, even though it's not required, it's important to make sure that we capitalize our class names because otherwise it looks like I'm just creating a function. If I capitalize it, then my fellow programmers will know, okay, no, this isn't a function, this is actually a class. Similar to a function, we do use the function keyword as well as the parentheses and the curly brackets. And as well, similar to a function, we want to put any input values in as arguments. So the inputs for a class are going to be whatever things are changing from the individuals. So we see that across these 3 different instances of assassins, that the code name changes, the weapon changes, and the stealthy value changes. That means those all need to be input values. So I'll have an input called codename, one called weapon, and one called stealthy. Trying to get this on one line, but it might just not happen. Ah, there we go. Okay, so here is the setup for our assassin class. So once we're inside of the class, we need to actually define properties. So whatever property we want to define, we define on the keyword this. So I would do this.codename, this.weapon, this.stealthy, and this.headcount. I'm not going to do the method just yet. So we'll get to the method in a minute, but I'm just going to start with the 4 properties. All right, so we've created the 4 properties. So now our assassin has a codename property, a weapon property, a stealthy property, and a head count. But right now they're all going to be undefined because I haven't saved anything in. So I want to save the values in for the first 3 based on the input. So I can, just like I was saving a value in a variable, I can do stealthy, right? And then we'll set the head count equal to 0 because notice that in every case, the head count defaults to 0. So let me clarify what's going on in each of these individual lines because it can be a little confusing at first. So I have this.codename equals codename. So over here on the left side of the parentheses, this is me actually creating the property. I'm saying I want a property called codename. Over here on the right side of the assignment, I'm saying use the value from this parameter. So if instead I had my parameters set equal to X, Y, and Z, I would change these values to X, Y, and Z. And it would work exactly the same. The code's less readable now, but it's saying, okay, take the first parameter and store it in a property called codename. Second parameter, store it in a property called weapon. Third parameter, store it in a property called stealthy. But I will go ahead and put those back because it's a little more readable that way. And then head count always defaults to the same value, so we can hard code in 0 as a starting point. So that's it for you. I have just created the assassin class. So now instead of having to write out every single assassin individually, I can instantiate them in one line of code. So I'm going to actually comment out these guys because these are a nice example of what not to do. We'll leave them there for now so we can compare them in a minute, but let me go ahead down here and create these same objects using our class. So I will start with our, who's our first one? Ninja Assassin. All right, so whenever you instantiate a class, so what I mean when I say instantiate, I'm just saying create a new specific one of these. So assassin is a general term. It's like a type, whereas an instance of a class would be a specific version of it. So in general, this tells us what our assassin's like. But if I want to create an assassin instance, that would be a specific assassin. So our ninja assassin is going to be an instance of the assassin class. So when I call my assassin class, I do call it with parentheses like a function, but I also have to use the keyword new. So the keyword new is our way of telling the code, hey, this is a class, not just a function. And we'll talk in just a minute about in a little more detail about some of the things that the keyword new does. So now I need to put in my inputs, my arguments. And just like with functions, we use the words parameter and arguments to specify inputs. So the code name is Hollow Eyes. The weapon is a katana. And the stealthy value is going to be true. I'm going to give up on everything being on one line. So let's scroll that over. Okay, so I have just created my ninja assassin. I admittedly haven't done the kill method yet, but all the properties should be in place. And sure enough, ninja assassin is an object. So now we have created an object in this streamlined way. So if we want to now create our other 3 assassins, we can do that super quickly. So let me go ahead and do that. We have our character assassin. Putting in different arguments for this one. And false, okay. And now let's create our ghost assassin. Okay, here we go. And let me go ahead and just console log all 3 of these so that we can be sure that they all came through as expected. All right. And finally, let's do our ghost assassin. Okay, let's run the code. And over here on the console, all 3 appeared. So except for that kill method that we're still going to get to, they've all come through exactly as planned. So let's take a minute to talk about why this class approach is way better than just explicitly writing these out. For starters, let's think about the amount of code we wrote. So this started on line 4 and ended on line 32. So that's almost 30 lines of code. Down here, this is 10 lines of code. So we did the same amount of logic, but on a third of the amount of code. But think about how this would scale as well. If I had 100 of these I need to write, we'd have to have this much code for every single new assassin. And then down here, every time we want a new assassin, it's just 1 more line of code. So I know it's wrapping because it's kind of a long declaration, but each of these is just 1 line of code. So every time we want a new assassin, now it's super simple to do. The next reason, apart from just saving time and space, is that it makes it really easy to change things. So let's say that instead of stealthy, we wanted for some reason to change this to has stealth. So if I change the key name to has stealth, I've changed it in 1 spot, but it's still going to be the same in every other one. So I would have to go through, once again, if we had 100 of these and change this value in 100 different places. That's really bad. That's a really good way to make a mistake. And that's a big reason why we don't like to repeat ourselves. However, down here, if I wanted to change the name of it, I could just change it in 1 spot. And now every single one of these has the key name changed. So classes allow us to change code really easily, and we just have to change it in 1 spot, and it changes for all of them. So hopefully I've convinced you that this is a much better way to go about it. I will now delete that what not to do, and we can stick with just this class code. So here we have it. All right, the next thing I want to talk about with classes is this new keyword. As I mentioned, the new keyword is important for instantiating classes, and let me explain exactly why. So when this code is run, this class code, a couple things are happening behind the scenes. The first thing that happens is an object is created called this. So I'm putting it in comments to indicate that it's happening automatically. So we don't have to write out this code. It happens for us automatically. So this becomes an object, and that means that we can just start putting properties directly on this. The next thing that happens behind the scenes is that we return this object at the end. So these are kind of the most critical things that happen. We have this keyword that is an object that we can work with, and then at the end it is returned. So let's talk about what happens down here. When I call the new keyword, it's telling the code that when we run this, what could be considered a function, that this object should be returned. So notice that there's no return statement in here. We haven't written return anywhere. Yet, when we call assassin, we get an object out of it. When we're just working with a function, that wouldn't work. This bit of code would resolve to undefined because there's no return statement. And in fact, if we get rid of our keyword, then assassin runs exactly like a function. And notice that our first object becomes undefined. That's because the only way to get an object out of a function is with a return statement. But when we have our new keyword, we're not running this like a function. We're running it like a class instantiation, which means that we get our object out without having to write return. It might seem trivial because it's not that much work to write out return this, but it's something that, you know, if you're writing hundreds of class types, that's just one line of code that you don't have to bother with. So that's really nice. There are a couple other nifty things that new provides for us, but I'm not going to go over them right now. All I'll say is that the keyword new activates some behind-the-scene logic, which makes these things, these class instances, a little more fancy than just your regular run-of-the-mill object. But for all functional intents and purposes, you're creating a new object with all these properties on them. So the next thing I want to talk about is methods. As I've mentioned a few times, we have left off our kill method, which is quite unfortunate because what kind of assassins are these if they can't kill anything? So there are two ways to add a method in. The first way is the most obvious, which is we can directly write it in here. Set it equal to a function and do this dot headcount plus plus. So there we have it, kill function. Easy enough. Before we do anything else, let's make sure it actually works. Kill, and then let's make sure that our head count has been incremented. There we go. Cool, so it looks like we can see our kill functions on there, and we can see that it's working and that our head count has been incremented. And if I instead ran this 4 times, we see there, or sorry, 3, I can count, I swear. We see that this goes up to 3. So that seems like it works. However, this is actually not the best way to create a method. So I'm going to also label this what not to do. There is a much better place to put the kill method, and that is on something called the prototype. So every class has something called a prototype attached to it. It is an object that exists on the class. So let's actually just look at it real quick. So if we, I'll console log it. So if we, oops, come on. Console log assassin.prototype. We see that right now, sorry guys, let me get rid of that. Okay, we see that assassin.prototype is an empty object. So on the assassin is this empty object called prototype. And this is basically a bank for methods. So all of our methods go in the prototype. So let me instead put that kill function where it ought to go. So we can do this dot headcount plus plus. Cool. So let me explain what's going on here. So keep in mind that assassin is the actual class, whereas these 3, the ninja assassin, the character assassin, and the ghost assassin, these are all instances of a class. So these are all specific assassins. They have the properties of, you know, of codename and weapon and head count. They have the kill method, whereas assassin doesn't have any of those. Assassin isn't actually a specific assassin. It's more of like a rule book of how to build an assassin. So it doesn't have these methods. These properties do not exist on the actual assassin object. There's just rules within this thing of how to put them on the instances. But assassin does have a property called prototype, and that is this communal bank where we store methods. So technically speaking, I'm actually putting the kill method on the rule book itself instead of on the instances. And in fact, if we go ahead and look inside of a specific instance, we'll see that the kill method still isn't there. So then why would we put the kill method on the prototype instead of directly on these instances? Well, it turns out that these things have access to the prototype. So if I run kill, it works. So notice that the head count has been incremented, and we have not gotten any sort of error about kill being undefined. So the reason is that the prototype is designed for this exact thing. When you try to run a method on an instance, first it will check inside of the instance to see if there's a kill method there. In this case, there isn't. So then it defaults to checking inside of the prototype. So the prototype is this communal place where we can put methods. And even though they're not directly put on each of these objects, when we execute them, the JavaScript will know where to look and know where to find it. So this might seem a little more convoluted and difficult than actually putting it directly on the objects, but there's a really good reason to do it this way. And the reason is that when we do it, if we were putting it specifically on each object like this, that would mean that when I create this ninja assassin, we create a copy of the kill function in memory. When I put it on the character assassin, we create a second copy. When we create the ghost assassin, we've just created a third copy. If we created 1,000 of these assassins, which why wouldn't we? Who doesn't want a team of 1,000 assassins working for them? If we created 1,000, then we would have 1,000 copies of this function in memory. And to be fair, functions don't take up a ton of space in memory, but they do take up something. So we've just wasted our memory creating 1,000 copies of exactly the same function. So if we are the baddest crime boss in all of the land, then presumably we have a lot of assassins to keep track of. But you know, we want to be cost efficient. We don't want to be spending extra money or resources on memory when we could be, you know, buying a pet tiger or having a solid gold toilet seat or whatever crime bosses buy. So we have to be efficient with our code, right? So in this case, there's literally one copy of the function in memory. So even if we have 1,000 instances of assassins, they're all using this one copy of the function. And there's no reason not to, because it's exactly the same function that they're all using. So it's important to put our methods on the prototype, because then we're saving space and it's set up in a way where all of these instances can just communally use the same function. So with these properties, that wouldn't work, because the value is going to be different. Even though the head count is starting in the same place, it needs to increment differently for the different instances. So it makes sense to create a new copy of these every single time. But with methods, they're going to be the same across all instances. So we want to store them in the prototype. So that's a little bit about how to create methods. So that is creating classes in a nutshell for you. So this is a bit more advanced than some of the things we've seen so far. So let me just go over everything I've just taught you one more time. So first of all, when do we want a class? Well, if we find ourselves creating a bunch of different objects with the same properties and the same methods on them, that's a good time to create a class. We declare a class by first of all, naming it with a capitalized variable. And then we use the same syntax as a function. We use the function keyword and whatever parameters we need. Within it, it looks a little different than a function. We don't use a return value for starters, and we also pretty much just assign properties. So we assign properties by taking whatever value, whether it's coming from a parameter or coming from somewhere else, and we store them on the property name, which we attach to the this object. And that's how we create properties for our instances of our class. And then when we want methods, instead of creating them directly in here, which will cause wasted memory later down the line, we actually declare them directly on this object called the prototype. And the prototype is an object that lives on the actual class object. So on the prototype, we can create however many functions we wanted. So if we had another method down here, maybe deceive, I'm not sure, oops, spelling. Maybe the deceive method just console logs, I am not here to kill you. Now we've, if we had 1,000 methods, which would be a lot, but if we had 10 methods, we could put all of them on the prototype, and then that way only one copy of each of these functions exists in memory. And then to create instances, we just name our instances, we run the class variable just like a function, except that we add the keyword new. The keyword new is critical. If we leave it off, then this is going to run exactly like a function, which is not good because there's no return value in here. As well, we might have problems with the prototype. But using the new keyword, we create new instances or copies of our assassin. So over here, I've created 3 different assassins. And then we're free to use our methods and our properties at will. And that is how you create a new class and create instances of your new class and add methods onto it. So the last thing I want to cover with this code I have up here is the keyword this. So I briefly introduced the keyword this last night. But the example I gave last night wasn't very good because the keyword this wasn't necessary. So let me show you in this method why the keyword this is really important. And we'll use the opportunity to talk a little bit more about what this actually does. So notice here that we have to use this because let's start by trying this. If I did assassin.headcount++, this is not going to work. And the reason is that keep in mind that assassin isn't an instance, it's the rule book. So assassin doesn't even have a headcount property. And if I tried to run this, let's see, nothing happens. Yeah, so headcount doesn't increment. So even though I'm calling kill down here, headcount stays at 0. And that's because the assassin is the rule book, not the instance. So we want ninja assassins headcount to increment, not assassins, totally separate objects. So of course I could hard code in ninja assassin up here if I wanted. And now it runs all right, but it only works for this one instance. If I tried to do character assassin.kill, then it would increment the head count for ninja assassin. So we definitely don't want to hard code in an instance here. That's why we use the keyword this. So this is kind of a placeholder word for whatever instance we're going to be working with. So this is saying whichever instance we call kill on, increment that instance's head count. And this can get a little confusing. With more advanced code, it can get pretty difficult to tell what this is actually referring to. But a good rule of thumb is go to where the method's being called and see what object it's being called on. So whatever is on the left side of the dot, that will be what this refers to. So when I run line 26, up here, this refers to ninja assassin. But if I ran ghost assassin.kill, then this would refer to ghost assassin. So this is kind of a stand-in word that refers to whatever instance we're running the method on. And it's really great because we wouldn't be able to write this kind of logic if we didn't have access to the this keyword. So super useful keyword when we're creating classes and especially methods. So there you have it. That is the Ninja class for you. The last thing I want to talk about tonight kind of ties into the first thing I mentioned tonight, which is this idea of everything being an object in JavaScript. So let's bring it full circle. So as we saw tonight, we got a little bit of a behind the scenes look into how we would create a data type. As it were, when the JavaScript developers were creating strings, for example, they were doing something very similar. They were creating basically a rule book for what is a string. What kind of properties do strings have? What kind of methods do strings have? How do strings work? So a lot of the same type of logic that we're doing here, the same type of thinking, is what the JavaScript developers were doing when they created strings or arrays or Booleans. It's a little more, those are a little more nuanced than just the type of instances we can create with a class, which makes sense because they are built in. But it's a very similar thing where the JavaScript developers explicitly defined what properties are on strings, what methods are on strings. And to prove it to you, I think that we should look inside of the prototype. So I'm going to go ahead and open my console because it's easier to see this in the console. So that, once again, on a Mac, that's Option-Command-J to open the console. And I apologize, the console is pretty small, so I hope this isn't too difficult to see for you guys. So if we want to see what's inside the string prototype, we can just do string.prototype. And if I open this up, it turns out that all of these string methods are listed here. So just like we saw over here where we stored all of our assassin methods on the prototype, we can actually look inside of JavaScript and see all of the string methods hidden inside of string.prototype. I can do the same thing with array.prototype. So here's all the array methods hidden within the array prototype. We could do boolean.prototype if we wanted, but it's a bit less interesting because Booleans don't really have many methods. And in fact, these methods are really things that are just kind of built into objects. And if we do objects.prototype, we can see a couple of object methods in here as well. So I wasn't being totally honest when I said that we have to write all our own methods with object. There are a couple that are built in, but mostly with objects, we write our own methods. Which brings me to the next thing I want to show you, which is that now that we know a little bit more of what's going on behind the scenes and we know about prototypes, we can actually start to customize methods on other data types. So let's go ahead and get rid of all this assassin stuff and do something a little crazy with arrays as a nice little fun final thing to close up this lecture. So I noticed a question in the channel last night. I can't remember if I addressed it or not about popping. So let me create an array. Throw some numbers in here. So as we know, we have this array.pop method. And this thing will pop off the very last item. And so I think someone asked, well, what if we wanted to pop off like the second item? Well, it turns out that we can do that. There isn't a built-in method for it, but if we want, we can build our own. So let's call this, so we want to put it on the prototype, of course. So array.prototype, we'll call it pop second. Actually, pop second is going to be a little bit advanced. So let's start with return seconds. So this, oops, and that is a function, syntax. So this thing will just return the second item in the array. So if we want our second item, we have to access it. And of course, in this case, we would use our this keyword. So this at index 1 is going to be our second item. And keep in mind, this will refer to whatever array we're calling this method on. And then let's just go ahead and return it. So now if I want to do array.secondItem, return second. We can call it. And if we created a new array, we'll call this characters. It's going to have random alphabetical characters in it. And we could also call chars.return seconds. And it works on that one as well. So using the prototype of array, I've just created a new array method. So now every single array has access to this method. And that's really great because sometimes you do want to do it. Sometimes your code calls for some type of array logic that you're going to be doing over and over and over again. And in that case, you probably just want to add a new method to the prototype. So now that we know that arrays are secretly objects behind the scenes, we can start to use that knowledge to help us. So if arrays are objects, that means that they also have methods and that we can access those methods. And using some of the things we learned tonight, we know that methods live on the prototype. So we can actually access array.prototype and write our own array methods. So, and if we wanted to actually do a pop second method, the logic would be a little more advanced because we also have to delete it, but we could write. I don't think I'll do that right now unless you guys really want to see it, but we could do pop second. And write our logic in here. And now all of our arrays have access to this pop second method where we can actually pop off the second item. Or we could even do pop specific, and it could take in an index, and we could pop off whatever item exists at index I. So even though we're limited in what's built into the array methods, we can always create a customized one if we want to. So I know tonight was pretty heavy duty, and as you might imagine, the homework for tonight is also pretty heavy duty. So I'm going to talk a little bit about it, and then so I'm going to talk a little bit about the homework, and then I will open the floor to questions. And we have plenty of time for questions, and I want to address clarify anything I can before you go to the homework. So feel free to ask whatever is on your mind. But first, a few words on the homework. So the homework tonight is a little different in that there are only a couple questions on it. I think only 3 questions. And the reason is that the questions are a little more difficult. And so there's a lot of pre-written code. So I've actually created a class for you. So I've created an HTML class. So once again, this is JavaScript code, but I've created a class called, I believe it's called HTML elements. So in the homework, you will see that there's an HTML element class that I've created. I've defined some properties. I've defined some methods. So it's up to you to use the class that I have created. So there's a lot of code that's going to be arriving to you already written. And that's because I want you guys to practice reading code. It's a really difficult and really critical skill to have, is to be able to read other people's code. So a lot of the homework tonight is just going to be spent trying to understand the code that exists on the page. And I've commented it out, which should help a little. And you don't have to understand every line of it. You have to just understand enough of it to be able to use it. So you'll be creating some instances in the questions, and in one case, adding a method. But once again, not too many questions, but the challenge here is to try and understand the code that exists on the screen. So that's a little note about the homework. I hope you guys enjoy doing that. It was actually a lot of fun to write because I actually got to write some code for once. But now let me open the floor to questions. I think there are already some in Slack. Let me see what we've got. So Joe asked, don't we want to avoid adding methods to the predefined parent prototypes like array.prototype? Not necessarily. One thing I would say that you want to avoid is overwriting existing methods. So if I did array.prototype.pop and decided that pop should do something totally different. So in this case, I think pop should just console log So now if I have an array and I run array.pop, I get pop has been overwritten logged and nothing has been popped off. So unless you have a very good reason to do this, I would avoid this because chances are this will result in some other developer trying to use pop and something unexpected happening. So we can overwrite the existing methods, but we probably want to leave those alone. It could be fun to troll your fellow developers though. So maybe a nice mean skill to have under your belt. But as far as actually adding them on, that's completely allowed. You do want to add them onto the prototype specifically instead of adding them to individual arrays, but that is completely allowed. So yeah, I would not say to avoid that. It can be extremely useful, in fact. Okay, we have another question. Does order matter when you're making arrays? So there are a few different ways to answer that. In one sense, yes, order does matter. So because arrays are totally ordered. So if we want to access the first item, we use array.0. So if this were in a different order, this lookup would yield something different. However, from a functional viewpoint, it kind of depends on the data that's in the array. So last night, I gave the example of a to-do list. So my to-do, we'll go ahead and create another to-do list, and you guys can find out what I'm up to tonight. So my to-do list for tonight is I have to go pick up a rug at my friend's house because I live on a cliffside and UPS doesn't deliver here. So I have to have large items delivered to my friends' houses. So I have to go pick up a rug. Then I'm going to make dinner, and then I'm going to clean out my car. So that is my to-do list for tonight. So in this case, order would matter because this is actually the order I want to do these things in. So if I rearranged it, the code might get confused because if we're trying to think of the first item as being the next thing I need to do, if make dinner is first, then some confusion could arise. But if this is just a list of things in my pantry, I have some tortillas. I have some coconut milk. I also have some peanut butter. Now it doesn't really matter what order I put these in because it's not really ordered data. But it would matter in terms of looking it up. So if I'm specifically trying to find tortillas and I know it's at index 0, things might get confused if tortillas were moved to the end of the array. So a little bit of a side note from the lecture tonight, but definitely important to be understanding arrays as well for what we're doing here. So I thought I'd answer that question. Okay, here is a question about classes and constructors. Okay, so I might need clarification on this, but let me read Chris's question. So, or Christopher's question. Does the constructor function, the prototype, contain the properties that are assigned to the newly created object or only the new created object? So two things I want to say. Let me do some backpedaling here and see if I can get us a class back. I should have left the code up. Come on. Sorry, guys. Bear with me. Okay, cool. We're back. Here is our assassin. So I think what Christopher was asking is, does the assassin itself also, well, first of all, he referred to the prototype as being the constructor. So let me clarify this. There are two objects here. The assassin itself is an object. Well, everything's an object. So the assassin is an object. And let's go ahead and just console log assassin. So we see that, and I'll get rid of this nonsense at the bottom. So we see that the assassin is just a function. And the assassin doesn't really have any properties on it, or any properties would just be a property that a function itself has. So the assassin itself doesn't have a .codename property, for example. If I run that, I get undefined. If I run assassin.headCount, I get undefined. So these properties are not going on the assassin itself. They're only going on the instances. So the assassin is one object, and it does not have any of these properties. And the assassin would be the constructor function. So I kind of said the word rule book. That's a good way to think about it. But technically speaking, we would call the assassin the constructor function. So now let's look at the prototype. Assassin.prototype, prototype is a thing that exists. So we would say that assassin does have some properties on it. For example, assassin has a prototype property on it, which refers to right now an empty object. So we can see that by default, prototype is empty. So prototype also does not have a code name. It does not have a weapon. It only has what we explicitly write on it down here, which in this case are these two methods, kill and deceive. So to answer that question, these properties we define in the constructor only exist on the instances. The instances will have these three properties, or four properties. The constructor function will not have these properties, and the prototype will not have these properties. Only the instances will have them. Okay, so we have another question. We have a question about prototypes. So specifically, it was asked, why can't we just put assassin.kill? And so the reason is that, and let me go down here and actually run ninja assassin. Let me bring this code down here. Sorry, 1 second. So I'm going to, what have I done? 1 sec, guys. I'm in a copying and pasting frenzy here. Okay, so up here, I've left deceive on the prototype, and I've moved kill onto the assassin directly. So let's see what happens when I try and run ninja assassin.kill. So we get ninja assassin.kill is not a function. We get an error. And that's because when we run a method, the first thing that happens is we look inside of ninja assassin for a ninja assassin.kill property. And ninja assassin.kill property does not exist. It is undefined. And we can tell because when we log out the ninja assassin, it's nowhere in there. So when we run ninja assassin.kill, first it looks inside of this object itself. However, if it doesn't find it, it doesn't give up. The second place it looks is inside the constructor's prototype. So specifically, it looks inside of the prototype. So the kill function is not in the prototype. So right now, it's saying error. Kill is not a function because it can't find it. It's looking first in this guy, second in the prototype. But the kill function isn't in either. So yes, we have to put the methods on the prototype because that's where it looks. That's exactly what the prototype is designed for. So rather than being a method on the constructor, it has to go on the prototype or else we won't be able to find it. So that's a little bit of a note of why it needs to go on the prototype and not on the constructor itself. As a reminder of why we shouldn't put it on the instance, we can. It's not the end of the world. It'll work, but it's just not the best way because it uses up extra memory. So we could define out kill in this way, but it'll use up extra memory, so we would rather put it on the prototype. Okay, hopefully that answered your question about the prototype. Do we have any more questions in Slack? All right, things are looking pretty quiet. I'm assuming that's because your minds have all been totally melted by all of this awesome new information. Oh, wait, I see a couple more people typing. Let me hold off so I can answer their questions before we call it a night. Oh, yep, everyone is confirming that it is stunned silence. Yep, everyone's minds have successfully been melted. That means that my work here is done. Cool, so now that your minds are melted, I will just leave you in your bafflement to struggle with the homework. One thing I did want to note about the homework in general is that the homework is written with the intent to challenge you. So from my perspective, writing the homework, yes, I want to give you guys practice, but I want to also kind of push you to your limits, make your minds hurt a little bit. So hopefully you're not too mad at me having now admitted that, but I wanted to share that with you because I don't think that the expectation for me is not that you're going through the homework and you're like, yeah, this makes total sense. I've got this. This is super easy. The expectation is that you're going through the homework and you are struggling a little bit and you are having to rack your brains. So if you're struggling with the homework, don't let that be an indication that you're not learning what you're supposed to be. The homework is designed to push you. So keep that in mind tonight. Be patient and forgiving with yourself. And as always, reach out in Slack if you have any questions. Always happy to answer questions that are sent to me directly, but I don't always get to them right away. So recommend posting them in the channel first. And then if you want to ask me something specific, feel free to message me as well. So good luck with the homework tonight. And tomorrow night we have our very last lecture. I'll be sad to see you guys go, but also excited because you'll hopefully be moving on to the main curriculum and putting all this knowledge to even cooler uses. So good luck with the homework. Thanks for listening and have a great night, you guys.